behalf of UMEX Scientific, I'm pleased to welcome you all to today's webinar, Headlines in Occupational Hygiene Air Sampling, the third in this series. Today we're fortunate to have Debbie Dietrich, the Vice President and CIH from SKC, to present on this topic. I'll now hand over to Debbie Dietrich, who's kindly agreed to present from Houston.
Okay, hello Australia, and welcome to another edition of Headlines in Hygiene Air Sampling. Thank you very much for being a part of this transcontinental training event. It is my goal today to bring you the latest news regarding sampling methods and media in our profession. As new issues emerge in air sampling, we plan to continue the series of webinars throughout the year, so stay tuned for future events. Okay, so on this slide you can see the newsworthy topics in air sampling that I will discuss today. First is a new method just released by US OSHA for hydrogen peroxide. Then we have two new methods from NIOSH that specify so-called internal capsule samplers for particulate matter. One method is for total particulates and the other is for elements or metals. And finally, I will discuss a passive sampler for nitrogen dioxide validated by SKC research chemists for sampling at occupational or environmental levels. Okay, so let's begin with hydrogen peroxide. You know, this chemical really has a lot more applications in industry than you may realize. I did a little internet research and found that about 60% of the world's production of hydrogen peroxide is used for pulp and paper bleaching. As consumers, I'm sure many of us take advantage of the bleaching properties of hydrogen peroxide, whether we're hair lightening or teeth whitening, right? Hydrogen peroxide makes us all look a little more beautiful and heals your wounds in the meantime. It also is used as a disinfectant for wastewater treatment, to remove organic impurities, and to reduce odors from sulfur compounds. In the medical field, hydrogen peroxide is used to sterilize surgical tools and surfaces. So a lot of things that it is used for. Historically, hygienists evaluating hydrogen peroxide exposures had to rely on glass impingers for sample collection. Boo hiss. Nobody likes impingers. One of my honest-to-God favorite sampling stories that I've always loved to tell is from a Texas hygienist who told me he simply refused to use impingers. In his company's hydrogen peroxide unit, he told me that he simply waited to see if any brunettes turned blonde. Then he knew he had an exposure issue. But that may be one of those Texas tall tales for which our state is famous. The good news is that you can now get rid of the impingers and you don't have to wait for blonde hair. No. US OSHA has just released method 1019. Hallelujah. This method specifies the collection of hydrogen peroxide onto two 25-millimeter quartz filters. The filters are chemically coated with titanium oxysulfate and are analyzed by spectrophotometry. These filters are available from SKC preloaded and pre-coated using the catalog number shown here, 2259030. Method 1019 was just released this year. It is posted on the US OSHA website, and you can easily find it doing a general internet search. I do this every day. I just type in, NIOSH method, whatever, OSHA method 1019, and boom, you will end up with the OSHA or NIOSH, if it's a NIOSH method, is one of the choices. If you ever have any problems finding a NIOSH or OSHA method, just send me an email and I will link you to it. Over the last several years, U.S. OSHA has been publishing a number of new methods using chemically coated filters. And honestly, if you can love a sample media, I love chemically coated filters. And here's why. Oops, sorry. You can say goodbye to impingers. They are a welcome alternative. They are also suitable for the collection of many multi-phase compounds. In other words, compounds that may be present in the workplace, both in the vapor and aerosol phase. For example, the U.S. OSHA methods for isocyanates use chemically coated filters because spraying operations for these compounds can produce both vapors and small droplets of isocyanate materials. And both are effectively trapped onto a chemically coated filter. And in this case, OSHA recommends open face sampling. This slide shows some special notes on the coated filters for hydrogen peroxide. For a few years now, SKC has been offering these coated filters to meet the specifications of a French agency method for this compound. And we've had them for a few years now. What is new today is that U.S. OSHA has now validated a method using these very same filters. Finally, a special note, be sure to protect the samples from light during shipping and storage. SKC supplies foil with the filters for this purpose. Okay, so now let's move on to headline number 2, new particulate sampling issues. Now, in recent years, both U.S. NIOSH and OSHA have been addressing the issue of sample loss that can be evidenced with traditional filter cassettes. And these sample losses are the result of particles that stick to the side of the cassette walls and are never analyzed. In the latest version of the U.S. OSHA method for hexavalent chromium, OSHA points out that more hex chrome can sometimes be found on the side of the cassette than on the filter itself. So given this reality, OSHA issued an instruction that the cassette walls of filter samples must be wiped by the lab prior to analysis. This is to ensure all collected sample is analyzed. In an AIHA journal article, NIOSH reported similar findings for filter samples of lead and copper. And they concur with OSHA that filter cassettes should be rinsed and wiped prior to analysis. Now, rinsing and wiping cassettes is an effective remedy, but this can be quite labor-intensive for labs that are processing a high volume of filter samples. So a new sampler design called an internal capsule sampler was developed to completely eliminate the problem of these cassette wall losses. And NIOSH now specifies an internal capsule sampler in 2 new methods. The first method shown here is the NIOSH 0501. This is for total particulates using a design SKC manufacturers called the Accucap. The Accucap consists of a clear plastic dome heat sealed to a PVC filter. Okay, PVC in this case. It is essentially a filter insert that is placed into a two-piece 37mm cassette with support pad. The advantage of the Accucap is that all dust drawn in by the pump is collected either onto the filter or onto the dome and is diced gravimetrically. Everything is captured and analyzed. Now, given the advantages of the Accucap for gravimetric analysis, which came out a few years ago, NIOSH decided to use the same concept for chemical analysis of metals. Okay. In this case, the internal capsule sampler has an acid digestible dome material that is heat sealed, in this case, to an MCE filter. It's being used for metals. SKC calls this design the Solucap, and like the Accucap, the Solucap is placed into a traditional 37mm two-piece cassette with support pad. After sampling, the entire device is acid digested for ICP analysis. Now here you can see NIOSH method 7306. This was released late last year for the collection of elements or metals using what they call, in generic terms, cellulosic internal capsule sampler. The method validation was done using the SKC Solucaps. Now, note that traditional filter methods are still being used, but the internal capsule samplers, again, offer the advantage of complete sample collection and analysis without wiping the cassette walls. Now, I know in Australia that the standard sampler for particulates is the IOM sampler. So I just wanted to take a moment and kind of compare the internal capsule samplers to the IOM cassette and filter for different applications. If we look strictly at gravimetric, the Accucap with a PVC filter basically accomplishes the same thing that we get from the IOM, in that with the IOM, the filter and cassette are weighed together. So there is no concern over cassette wall losses. You're weighing them together. Anything stuck to the side of the cassette is weighed. The advantage of the Accucap compared to the IOM cassette would be simply that it is totally disposable. Where the IOM cassettes, you typically wash and reuse based upon the price. And one of the main goals that NIOSH had with these samplers, they wanted to have something that was completely disposable, at a low cost as well. Now, if we then look for chemical analysis, with the IOM cassette, of course, the filter is removed from the cassette for analysis. I'm not sure if in Australia labs are routinely rinsing and wiping the IOM cassette. The IOM cassettes are not, they're conductive, so you don't have the issue of static electricity, and metals are not just sticking to the side from static. So I'm not sure if they're rinsing and wiping. But again, with the Solucap, you have the advantage, there is no need to remove the filter or rinse or wipe the walls. You simply acid digest the entire device. And again, the sampler is disposable. So again, I know in Australia the IOM is the standard, but again, we're having a transcontinental exchange of information. So I wanted to let you know of some of the things we have over here in the States and kind of what NIOSH's thoughts were to behind it. They're really, really set on having an inexpensive, disposable sampler that eliminates these wall losses. Okay, as my final headline today, I will discuss sampling developments for nitrogen dioxide. And you may be thinking, what? Who cares about that chemical? What's newsworthy with that? Well, actually, nitrogen dioxide is a very significant chemical compound since it has both occupational and public health considerations. Let's first look at occupational issues. You know, one of the first occupational illnesses I remember learning about as a student was silo filler's disease. And I thought, I will never imagine myself working around silos, but okay, I was interested in learning about this disease. This respiratory illness afflicts farmers exposed to nitrogen dioxide when some of these nitrogen-containing materials such as corn and grains ferment. But nitrogen dioxide concerns are not limited, of course, to agriculture. In general industry, nitrogen dioxide is a concern in welding operations and electroplating, and it is a primary component of diesel engine exhaust from heavy equipment. Nitrogen dioxide is also a major environmental consideration. This gas is formed when fossil fuels are burned at high temps. U.S. EPA reports that emissions come principally from vehicles, as well as power plants, industrial sources, and off-road equipment. Nitrogen dioxide itself produces a number of adverse respiratory effects, and it reacts with oxygen to produce another chemical hazard, ozone. Environmentalists also note that nitrogen dioxide contributes to acid rain and eutrophication. There's a new word for me. I honestly had to look this one up when I read this on the EPA website. Eutrophication is when a chemical in the air causes an explosive growth in underwater plant life, depriving aquatic animals of oxygen. Now, nitrogen dioxide is one of the key parameters really used around the world in these so-called near-road monitoring stations. This is where environmental professionals assess the effects of vehicle exhaust on health. That's one of their big words we use over here at US EPA is near-road monitoring. Now, why is this a big deal? US EPA reports that 16% of housing units in our country are within close proximity to a highway, railroad, or airport. And even city planning commissions will investigate nitrogen dioxide levels as they consider pedestrian areas or bike paths for their community. And many community action groups will actually buy inexpensive nitrogen dioxide monitors looking at the same thing. So let's now look at occupational exposure limits. It honestly seems so strange to me that each of the U.S. agencies involved in industrial hygiene have different types of exposure limits. I've never quite seen this before. OSHA has a ceiling value. NIOSH has a STEL. ACGIH has a TWA. That was something for everybody, which, by the way, was lowered significantly in 2012 At that time, it went from 3 ppm as a TWA down to 0.2 ppm. Now, existing NIOSH and OSHA sampling methods specify sorbent tubes with molecular sieve coated with triethanolamine or TEA. These tubes have been available at SKC as long as I've been here, many, many years, and still widely used. Now, using this same chemistry as these existing active methods, SKC research chemists developed a passive sampler that contains a TEA chemically treated paper tape inside a badge housing. The SKC UMEX 200 has a section of tape that is exposed to the air contaminant mixture and an unexposed section of tape that can serve as a blank or a correction layer. To collect a sample, the samplers are placed in the breathing zone and the yellow slide cover is moved to the on position, exposes the holes. At the end of the sampling period, the yellow slide cover is moved to the off position, basically covers up the holes. Now, the good news is that the samples are stable and require no freezer or refrigerated storage. Samples can be stored up to 3 weeks at ambient temps prior to analysis. Once it gets to the lab, chemists will remove the TEA-coated tape. There you can see the 2 pieces, one for the sample and one for the control or blank. They will extract with DI water and then analyze by ion chromatography. The analysis procedure is similar to the OSHA active sorbent tube method, but it has been optimized by SKC chemists to measure the lower contaminant mass that you would collect with passive rather than active sampling. Very simple, nice method. So in this slide, you can see the validation range for nitrogen dioxide. For occupational applications, the UMEX 200 can reliably measure nitrogen dioxide even at the lower TLV of 0.2 ppm. For environmental applications, the UMEX 200 can detect nitrogen dioxide down to 2 ppb for 24-hour sampling of ambient air. In my country, it can also be used for our national ambient air quality standard of 100 ppb for a 1-hour sample. So you can see very low levels. Note that SKC has also validated the UMEX 200 for sulfur dioxide. And here you can see the validation range. So for occupational sampling, the UMEX 200 has been validated for TWA sampling of SO2 for the OSHA permissible exposure limit of 5 ppm or the NIOSH exposure limit of 2 ppm. It has also been validated for STEL sampling for the NIOSH limit of 5 ppm. And although it was not done in the original validation study, the SKC chemist has advised me that the UMEX 200 can also be used for the current ACGIH STEL of 0.25 ppm. We just did some mathematical calculations to determine this capability. For environmental applications, like for NO2, the UMEX 200 can detect down to 2 ppb for 24-hour ambient air sampling for SO2. Okay, so thank you very much for your attention, and thank you to AirMet for arranging this event. So we'll see you next time, and I'll pass it over to Peter.
Thanks, Debbie, for your time today. Very informative and interesting presentation, as always.